How does a pop-up boat work? Well, to know how a pop-up boat works, first we have to know how it floats. And to know how it floats, we have to know what buoyancy is. Buoyancy is an upward force exerted by a fluid that goes against the weight of an object. The equation for buoyancy is F sub B equals rho GV, where rho is the density of the liquid that the object is in, G is the gravitational field strength, and V is the volume of the liquid that was displaced. For an object to float, the buoyancy force would have to equal the gravitational force pushing down on the object, which is mg. If these are equal, that means that the object is not accelerating. When the buoyant force is less than the gravitational force, the object will sink. Buoyant force is equal to the mass of the fluid displaced. This is known as Archimedes' principle. When two objects of equal volume are floating, the object with the greater mass will have the greater buoyant force acting on it, because there's more water being displaced with the heavier object. Therefore, there's more mass of the water being displaced. If two objects are submerged, they have the same buoyant force if they have the same volume. So, the boat will float because the buoyancy force acting on it is equal to the gravitational force, and the sum of the two forces is 0. Therefore, the boat's not accelerating downward or upward. So what is a pop-up boat? A pop-up boat consists of a boat with a boiler engine, a candle, and tubes that exit the back of the boat. To make one, you can use a sealed, airtight aluminum can, straws, a candle, and a carton or other boat-shaped material. What gets the boat to eventually move is heat transfer. First, you light the candle. In a candle, the fire has rapidly moving particles. These particles collide with the boat's engine and transfer heat to the metal of the engine and increase the average kinetic energy of the molecules in the water in the engine. The more conductive the engine metal is, and the more candles that are lit under it, the more heat will be added to the system, and the faster the molecules in the water will move. Molecules will collide with the engine faster and more frequently, making the engine hotter. The water in the engine heats up and steam is created. When the steam is created, this causes the engine to expand. Cooler water is then sucked into the engine through the straw, which removes heat from the system because the cooler molecules are moving slower and slow down the fast-moving molecules when they collide. The engine then contracts, which shows positive work on the gas and negative work on the engine. This happens over and over, so the engine is constantly expanding and contracting. This causes water to be pushed out of the straws each time, which causes the boat to move. This whole process can be explained using thermodynamics. To start off, we must know that U equals NK average, U being the potential energy, N being the number of particles, and K average being the average kinetic energy. Since we know that K average equals 3/2 K sub B times T, which is 3/2 Boltzmann constant times temperature, we can derive the equation U equals 3/2 NK sub B T. Since we know that PV equals NK sub BT, which also equals nRT, we can derive U equals 3/2 PV and U equals 3/2 nRT. According to the first law of thermodynamics, delta U equals Q plus W. Delta U is the change in potential energy, Q is the heat added to the system, and W is the work done on the system. The heat transfer of the pop-up boat can be seen in this graph of a heat engine. The first process is from point 1 to point 2, where the candle heats up the engine. During this, the volume is constant, so it is an isovolumetric process. The pressure increases. We know that U equals 3/2 PV, so we can see the change in U is positive because the pressure increases and the volume stays constant. U is proportional to temperature, so we can see that the temperature increases as well as the average kinetic energy. Since the volume doesn't change, no work is done. So Q is positive, meaning that heat is added to the system. The second process shows the volume increasing at a constant pressure, an isobaric process. During this time, the engine is expanding. Since the volume is increasing, there is negative work done on the system. Since U equals 3/2 PV, we know that delta U is positive again, so Q must be positive again. Temperature once again increases and heat is still being added. The third process is isovolumetric like the first, so no work is done. The change in U is now negative because pressure decreases and U equals 3/2 PV. The temperature and the average kinetic energy also decrease. Now we know that since delta U is negative and W is 0, Q must be negative for the equation to work. So, heat is being taken away. This is when the cold water is entering the engine through the straw. The fourth and final process is another isobaric process. The volume decreases as the engine contracts. Therefore, there is positive work being done on the gas. Since volume decreases and U equals 3/2 PV, delta U is negative, meaning that Q is also negative. For the entire process, delta U is 0 because the pressure and the volume are the same in the beginning of the process as the end of the process. So how does a boat actually move? During the expanding and contracting of the engine, water is being pushed out of the straws into the water. This force causes the boat to move because of Newton's third law. Newton's third law states that for every action there is an equal and opposite reaction. In other words, if I run into a wall full force, I am going to be pushed back with the same force that I applied on the wall. The water shoots out of the straw into the water, and the water pushes the boat back with an equal force. And that is the physics behind pop-up boats.